For decades, we have scanned the heavens. Not just for planets, not just for distant stars, but for the strange, the unexplainable, the anomalies that refuse to obey the rules. The James Webb Space Telescope was built for this very purpose, to cut through the noise of the universe and show us what hides in the darkness. There are documented 10 previously unknown moons, identified highly irregular magnetic fields, and encountered a planet whose features defied former models. Voyager 2 also found 10 new moons and a set of thin, dark rings that were almost invisible. The planet looked quiet, but its strange behavior didn't match what scientists had expected. With its primary mission completed, Voyager 1 redirected itself toward interstellar space. Voyager 2 pursued a longer trajectory, one that brought it closer to planets no other spacecraft has visited up close. In 1989, Voyager 2 continued onward to Neptune. It was the last stop, and it showed a world full of violent weather. The winds there moved faster than the speed of sound. Massive storms larger than Earth spun across the surface. It transmitted over 9,000 images, revealing a dynamic atmosphere with supersonic winds and turbulent storms. As it passed Neptune's largest moon, Triton, the probe gathered data that overturned several long-standing assumptions. Triton was covered in frozen nitrogen. Geysers sprayed liquid nitrogen into the air, which froze before it even hit the ground, a surface with few impact craters and signs of ongoing geological activity. Triton was also smaller than expected with very few craters. Its surface looked young, like it had been reshaped not long ago. The information from Uranus and Neptune wasn't just new, it was also the last humans have ever gotten. No other mission has gone back since. So everything Voyager 2 captured became one of the most valuable parts of the entire mission, a region where the sun's light fades and space begins to play by different rules. What had begun as a 5-year planetary survey turned into the longest-running space mission in history. A mission that extended far beyond Saturn, that reached the edge of the solar system, and eventually even beyond it. The heliosphere. The sound of space. Eventually, the planets ran out. There was no next stop. No more moons to photograph. No more rings to scan. Voyager 1 had passed Neptune's orbit and just kept going, heading for nothing. But nothing soon turned out to be the most interesting part of the mission, because the edge of the solar system isn't a clean line. It's messy and strange, and no one had ever actually seen it before. That edge is called the heliosphere. Imagine it like a giant invisible bubble blown outward by the solar wind, those streams of charged particles constantly pouring off the sun. The solar wind travels fast and far, but eventually it hits the stuff between the stars, the interstellar medium. And that medium, made of gas, dust, magnetic fields, and radiation, pushes back. That's the edge. And Voyager 1 was about to crash right into it. Scientists had long theorized about what that boundary might look like. Would it be a soft gradient or a hard wall? No one really knew, because no probe had ever reached that far. Most models were based on computer simulations and best guesses. For years, scientists weren't sure when or even if the spacecraft would cross that threshold. The Sun's magnetic field stretches far beyond Pluto, and nobody knew exactly where it faded into deep space. But in 2012, the readings started. The NASA says its Voyager 1 probe is sending usable information to Earth again. What if the edge of our solar system isn't the end, but the beginning of something stranger? After decades of silence, Voyager has crossed into the unknown, a region so chaotic even NASA was left stunned. And what Voyager found out there, it's not just strange, it's rewriting the edge of what we thought space could be. What kind of information is it beaming all the way back to Earth? The most distant man-made object. In late 2023, Voyager 1, the most distant human-made object in existence, began transmitting data that defied interpretation. For several weeks, the signals received were fragmented and disordered. It had no telemetry or readable content. Initial diagnostics suggested a hardware malfunction. Further analysis identified a deeper anomaly, a corrupted memory section within the spacecraft's flight data subsystem. One onboard chip no larger than a fingernail had likely been struck by cosmic radiation. Out there with no atmosphere to protect them, spacecraft are bombarded by high-energy particles. These rays can tear through circuitry, flip bits in memory, and corrupt critical data. It's like static on a cosmic scale, but with real consequences. The instructions it once stored were either lost or scrambled, making the system operational but impaired. Voyager 1 was still transmitting, but none of what it gave aligned with any known formatting or expected behavior. The only solution required reprogramming the main functions of the spacecraft's primary data system from over 15 billion miles away. This operation was never intended to be possible. There's so much to go through there. That is an incredible thing. Firstly, this process of basically repairing something so far away in kind of simple terms. Talk us through, how did they do this repair? Voyager 1 was initially launched equipped with hardware possessing less memory than a modern digital watch. Its flight data subsystem operates on under 70 kilobytes, less than the size of a single email header. The software had not been altered in decades. There were no backup systems, no alternate processors, no protocols for remote intervention at this scale, just a single probe in deep interstellar space and a limited group of engineers on Earth, many of whom had worked on the original mission, attempting to recover functionality from memory. Each transmission to the spacecraft required 22 hours to arrive, each response another 22 to return. Every line of code had to be manually converted into raw binary, assigned to new memory locations, and transmitted in fragments. A single miscalculation could result in permanent failure. After multiple failed attempts spanning weeks of silence, static, and trial execution, a new signal was received. The data was clean, structured, interpretable. NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again. Voyager 1 had successfully reinitialized its system. A spacecraft running on kilobytes had single-handedly recovered from a critical failure using remote instructions executed with no margin for error. It performed a system-level procedure no spacecraft in history had ever been designed to attempt, and it worked. It was not engineered for interstellar conditions. It was not constructed to withstand the environment beyond heliopause. Yet it continues to transmit. This is the record of a mission that was not supposed to survive. It began in 1977 with a launch that was never meant to last more than 5 years. 3, 2, 1, MDS, we have ignition. We have a liftoff. The greatest journey ever launched. In 1977, 2 nearly identical spacecraft were quietly being prepared for launch at Cape Canaveral. They were named Voyager 1 and Voyager 2, twin probes constructed by NASA, each assembled with less mathematical power than a pocket calculator. The mission, while ambitious, was expected to be brief. Both probes were tasked with observing the outer planets, collecting data, capturing images, and concluding their assignments within a few years. Voyager 2 launched first on August 20, 1977. Voyager 1 followed 16 days later. Despite launching second, Voyager 1 traveled faster, overtaking its twin shortly after deployment. The entire trajectory hinged on a rare planetary alignment, an orbital structure that occurs only once every 176 years. This timing allowed the spacecraft to utilize gravitational assists, going from one gas giant to the next and dramatically reducing travel time. NASA recognized the narrow window of opportunity and acted accordingly. Survival beyond Saturn was considered unlikely. The probes carried no backup CPUs, no artificial intelligence, no solar panels. Each relied on a radioisotope thermoelectric generator, a nuclear battery that decayed slowly over time, providing just enough energy to transmit small bursts of data back to Earth. These batteries don't generate electricity the same way solar panels do. Instead, they convert the heat from radioactive decay into electrical power, a slow, steady trickle that can last for decades. It's the only option when sunlight is too weak to be useful. But the systems functioned. What had once seemed like a distant mystery began returning with clarity. Voyager 1 reached Jupiter in 1979. It captured high-resolution images of storms, intense radiation zones, and the planet's vast magnet. Jupiter wasn't just a giant ball of gas. It was a powerful, dangerous world surrounded by radiation so intense that it could damage spacecraft within hours. But Voyager 1 made it through. In fact, it didn't just survive, it delivered discoveries that changed everything. It detected massive magnetic fields, faint rings, and plasma waves that had never been seen before. And then it spotted something no one expected. One of Jupiter's moons, Io, was thought to be lifeless, but it wasn't. Instead, it was covered in active volcanoes. Some were erupting with such force that they sent molten material hundreds of kilometers into space. Voyager also found something shocking in Saturn. Scientists had known about Saturn's rings, but they hadn't known how complex they really were. Voyager revealed details no one imagined: braided rings, strange gaps, and patterns shaped by hidden moons. Its instruments returned images that reshaped scientific understanding of the planet's rings, cloud systems, and overall composition. Voyager discovered that Titan, Saturn's largest moon, wasn't just big, it had an atmosphere, a thick orange haze wrapped around it, filled with organic chemicals. Some scientists believed it could be similar to what Earth looked like in its early years. Titan is unlike any other place in our solar system, and the most comparable to early Earth. Voyager couldn't see through the haze, but the clues pointed to something important waiting to be discovered later. As Voyager 1 moved on toward deep space, Voyager 2 kept going. In January 1986, 2 years beyond its original shutdown schedule, it arrived at Uranus, the only time any spacecraft has visited this distant planet up close. What it found was strange. Uranus wasn't upright like the other planets, it was tilted almost completely on its side, spinning like a rolling ball. Its magnetic field was even more confusing, twisted, tilted, and completely different from anything seen before. To shift. Plasma density spiked. Magnetic fields changed direction and charged particles disappeared. And just like that, Voyager 1 was outside, the first human-made object to leave the solar system. 6 years later, Voyager 2 did the same. But in an unusual occurrence, they didn't find the same things. Even though both spacecraft exited the solar system, their data didn't line up. Voyager 1 entered a region where interstellar particles were dense and compact, almost like invisible walls of energy. But Voyager 2 found something different, a kind of stream, a long stretched-out flow of particles reaching over 150 million kilometers into the heliopause. Same exit, 2 totally different doors. But that wasn't the only surprise. Voyager 1 had also lost its plasma instrument decades earlier. It could detect the presence of particles, but not their temperature or speed. Voyager 2, though, still had a working sensor, and what it saw made scientists pause. The plasma beyond the solar system was hotter than expected, almost 30,000 degrees Celsius. But because the medium was so thin and spread out, it didn't feel hot to the probe. It just floated through like a submarine through fog. Both Voyagers also recorded something else, something nobody had ever predicted. The edge of the heliosphere wasn't smooth. It wasn't a perfect shell. It was wrinkled, giant folds in space billions of kilometers wide, caused by waves of solar energy pushing and pulling at the bubble's edge. These folds moved and shifted, and in some places, they even chased the probes. What should have been an empty, quiet crossing turned out to be a noisy, chaotic mess. Everything scientists had modeled was wrong. Everything they thought they knew about the edge of the solar system was shattered. Something out there was different. And the deeper they went, the stranger it became. The Golden Record. Timothy Ferris and I produced the so-called Golden Record on the Voyager spacecraft. The Golden Records, a message to no one. Long before Voyager left the solar system, before it skimmed past Saturn or entered the interstellar deep, engineers attached something strange to its frame. It wasn't a sensor or a camera. It was a 12-inch golden disc attached to an aluminum case fixed to the side of the spacecraft like a quiet signature. This wasn't science. It was something else, a message not for us but for them. The idea came from Carl Sagan, an astronomer known for bridging science and the public. He assembled a small team of researchers, artists, linguists, and musicians. Their task was to capture the essence of Earth. They were given only a few months to decide how to represent the entire human species on a single disc. It wasn't just music or greetings in different languages. They included diagrams of DNA, recordings of a heartbeat, a stylized map showing our location in the galaxy drawn with pulsars as coordinates. It was humanity's greatest mixtape, sent to no one from everyone. The final record was part archive, part message. We still communicate with the Voyagers. They send us signals every day. You could see Voyager 2 is being tracked both by Antenna 35 and Antenna 36. An attempt to preserve a snapshot of life on Earth. It was not built with the expectation of being found. The chance of another civilization discovering a small metal disc attached to a drifting spacecraft was close to zero. But the point was never practicality. It was symbolism. It was the most human thing ever done in space. Embedded into the surface of the disk were universal constants, atomic diagrams, and detailed instructions for playback. These were included to ensure that if the record was ever found, it could be understood even by beings who do not see, hear, or think the way humans do. It was not a message meant for anyone specific. It was more a mathematical introduction, a declaration that a species once existed here, capable of thought, language, and music. The disk remains attached to the Voyager probes, protected only by a thin metal shell and the freezing silence of interstellar space. The odds of it being discovered are close to none. It may never be seen. It may outlive the Earth. It may continue drifting untouched for millions of years, but the purpose of the record was never about being found. It was about what it meant to send it, that even in deep isolation, it chose to create something lasting. A message that was both quiet and beautiful, but meant for no one in particular. The record's real purpose was never about being discovered. It was about what it said when we made it, that we existed, that we wanted to be known, that even in the smallest, loneliest corners of space, we chose to leave behind something beautiful. It wasn't a transmission. It was a whisper. Not for us, but for the silence itself. Destroy the agency. So the agency that had been able to do extraordinary things like Apollo was going to consciously transform itself to running a space transportation system. The glitch that almost ended everything. For a while, everything seemed steady. The Voyagers had made it past the planets, past the heliopause, and into true deep space. They were still sending data, running on scraps of power, doing the impossible every single day. But then, in late 2022, something changed. And it wasn't a small hiccup. Voyager 1 suddenly stopped making sense. Instead of clear data, it started sending back zeros and ones arranged in ways that didn't fit anything. Engineers checked the systems, hoping it was just a brief glitch. Maybe some cosmic ray had hit a sensor. Maybe the signal was just weak. But the signal was fine. It just wasn't saying anything they could understand. At first, nobody wanted to believe what it might mean. Voyager 1 had made it through everything: solar storms, radiation belts, 45 years of space. But the source of the problem was buried inside the spacecraft's onboard memory system. When it leaves the bubble, it will then enter interstellar space where there's an interstellar wind which has come from other stars that blew up. A part called the Flight Data Subsystem. This was the ancient computer responsible for organizing all the data before it got sent back to Earth. If the FDS stopped working properly, the whole mission would fall silent. This system wasn't designed to be repaired. Nobody on Earth had touched it since the 1970s. It was made of parts that don't even exist anymore. Documentation was limited. The engineers who built it had mostly retired or passed away. And yet, the team at NASA's Jet Propulsion Lab refused to give up. They started digging through decades-old manuals, searching for memory maps, trying to figure out what had gone wrong. After months of investigation, they made a wild guess. Some tiny part of the flight data subsystem's memory, just a few bits, had been corrupted. They couldn't go up there to fix it, so they had to work around it. Their solution was insane. They decided to rewrite the memory commands line by line and move all the important instructions to a different part of the system, one that hadn't been damaged. In April 2024, they sent the patch. It had to travel over 15 billion miles, taking more than 22 hours to get there. Then they waited, and when Voyager answered, it worked. The signal came back clean. For the first time in months, the data made sense. Voyager 1 had survived the unfixable. It had been repaired across space using nothing but math, patience, and a team of engineers who refused to let go. Just like that, the probe that was supposed to last 5 years kept going. Voyager 1 is the farther of the two spacecraft, and it's currently about 13 billion miles from us here on Earth, where they are now. Right now, both Voyagers are still out there, still floating through space, still awake, still whispering back to Earth across billions of kilometers. It's easy to forget that these two spacecraft, built in the 1970s, running on 8-track level tech, are farther from us than anything else we've ever made. Voyager 1 is over 24 billion kilometers from the Sun. Voyager 2 isn't far behind. Every second, they move a little deeper into the unknown. No destination or way to turn around, just this endless drift into silence. But silence doesn't mean stillness. The data is still coming, slower now and less often, but still very real. Voyager 2 still has a working plasma instrument, giving scientists fresh readings on the temperature, density, and speed of the interstellar medium. Voyager 1,